So now we're going to look at beta radiation. And this is the radiation that a neutron-heavy atom emits when it decays. That is to say that we've got some atom, some nucleus that's got too many neutrons. And so one way it can decay is by, as we were saying for alpha decay, a particular decay chain is for it to get rid of 2 protons and 2 neutrons, but that's not the decay chain that a lot of particles follow when they're unstable. And actually a nicer thing for them to do would just be to convert 1 neutron into a proton. And that's exactly what goes on here. So as we can see here, we start off with this unstable nucleus, but now we decay by beta minus decay, we call it, and we're going to end up with this electron. And remember, just as we basically called a helium nucleus an alpha particle, we're going to have a different name for electrons in this decay, but that is what it is. They are electrons. This actually isn't quite complete. There's actually a little bit we're missing here in this decay, so don't take this as an equation, but this is just emphasizing the key feature of beta decay, which is that we end up with this electron being ejected from an unstable nucleus, and then something going on here with this decay. So beta radiation just consists of fast-moving electrons, which here we call beta minus particles. In a later video, we'll see why the minus obviously is related to this charge, but we'll see there's also such a thing called a beta plus particle too. But we're not going to worry about that now, but that's where the minus comes from. So we call them a beta minus because they're negatively charged, and we just want to talk about the radiation, the electrons we get from radiation in a slightly different sense to just the electrons we have normally. But they are entirely just electrons. It's just, as you know, we had for this alpha radiation, we use this alpha particle instead of just calling it what it was, which is a helium nucleus. We do the same thing here for electrons in this beta decay too. So how do we depict a beta minus particle in our isotope labeling system that we had before? So this, you realise, is basically just like saying how do we depict an electron in our isotope labeling system, which is not something we really talked about. And so what we do is, we start off by just writing down the symbol, and that's just to write down a beta. That's it. So that's its chemical symbol. But just as before, we have to fill out an atomic number and a nucleon number for it. So really, for the nucleon number, we're not going to say number of protons. What we're going to say is its charge, and its charge here is -1. Because relative to a proton, its charge is -1, relative to a proton. So for a proton, remember down here, we'd have an atomic number, a proton number of +1. So here we're going to have a proton number of, an atomic number, which is a better way of talking about it now, because obviously we don't have any protons here, but we're going to see why that's going to be very helpful. We have this one of -1. And remember, for its nucleon number, we saw an alternative name for that was its mass number. And we saw the mass of an electron was so much less than the mass of a neutron or a proton or of a nucleon that we're going to say it has a nucleon number of 0.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.